Okay, so we want to sketch the graph of f of x here. So the first part is the domain. And there's domain errors wherever the denominator equals 0. And so I take the part inside the parentheses, set it equal to 0. I get 1. So the domain is all x such that x is an element of the reals and x is not equal to 1. That was if I plug in 1 for x, that would make it 3 over 0, which is undefined, so therefore that is not in the domain. B is to find the intercepts. So to find the y-intercept, I plug in 0 for x. And I get 3 over 1. So there's my y-intercept. My x-intercepts are, I plug in 0 for y. And so a fraction is 0 whenever the top equals 0. So I set the top equal to 0 and solve. Well, there's no x to solve for, so the top can never be 0. It's because the top is always 3. So there's no x-intercepts. Part C is to find the asymptotes. We have a vertical asymptote at x equals 1, a horizontal at y equals 0. The vertical is just really the domain, any x values that make the denominator 0. We put a vertical asymptote there. The horizontal, I compare the degrees. Since the degree on top is 0, because it's a constant, the degree on the bottom in standard form would be 2. Whenever the degree up top is smaller, the horizontal asymptote is always y equals 0. Next up would be the first derivative test. I'm going to, before I do the derivative, bring the denominator up so that I can just use chain rule. There's my derivative. The critical values are whatever make the top a 0 and the bottom 0. So 0 makes the bottom 0. I'm sorry, 1 makes the bottom 0. So I plug in, I test each interval into the derivative. So if I plug in a 0, I get a positive. If I plug in a 3, I get a negative. So now I can say f of x is increasing from negative infinity to 1, decreasing from 1 to infinity, and has a max at 1. Oh, wait a second. 1 is undefined, because when I plug it into the original, I get undefined, because there's an asymptote there. So I would say, and has no relative extrema. E is the second derivative test, so I'm going to use that 6. Oh, sorry. I need the second derivative. So I'm going to use that 6, 1 minus x to the negative 3 form. Take the second derivative, get negative 18, 1 minus x to the negative 4 times negative 1. I get 18 over 1 minus x to the 4th. The critical numbers are, again, 1. So I've got to test that guy out. It's going to go positive, positive, because the bottom is to the power of 4. So it's always going to turn out positive no matter what. So f of x is concave up from negative infinity to 1, union 1 to infinity, because at 1 we have an asymptote and it has no points of inflection. All right, lastly, we want to sketch the graph. So that would be part F, and I'll do additional points if needed. So what information do we have? We know that there's 0 at 0, 3, y-intercept at 0, 3. We know that there's a vertical asymptote at x equals 1. There's a horizontal asymptote at y equals 0. There's no x-intercepts. So now I know that the graph, I use the increasing, decreasing. So from negative infinity to 1, the function's increasing. So that means that it's got to be over here. That would be increasing. That would also match with my y-intercept because it goes through the y-intercept. And that would also match my concavity. So that's definitely what it is. But I'm going to need a second point over there. So I need a point, I don't know, let's say we plug in -1 for an additional point. On the right side, since it's concave upward, I'm assuming it does that because it can't be the bottom part. That would be concave downward. This would be decreasing from left to right, which the first derivative test agrees with, decreasing from 1 to infinity. So it looks like that's going to be the top, that's going to be the part over there. So we need some extra points on that side. So we'll go with 2 and 3. See what we get. So we plug those additional points into the original, which was 3 over 1 minus x squared. If I plug in a -1, I get a 2, so I get 3/4. If I plug in a 2, I get 3. If I plug in a 3, I get 3/4. And I already know that's going to approach that horizontal asymptote. On both sides. There is my graph.